Hi guys, welcome to this video. I apologize, I appreciate how frustrating this must be doing lessons like this. It's very frustrating for me as well. I'm going to run through this as quickly as possible to get it uploaded and get it as watchable and short as possible. To do that, I'm going to gloss over some of the methods which are spoken about. You have the PowerPoints and you're able to read through them yourselves, but I'll give a very brief explanation. You've done titrations before. In this one, you're looking at titrating ammonium iron 2 sulfate, which might also be called ferrous ammonium sulfate. It's kind of an old-fashioned name for it, or Moore's salt. You do that by making up a standard solution. You then titrate a very known concentration of it using a pipette against the KMnO4, which is in a burette. So you measure out your ammonium iron 2 sulfate using a pipette, and then you titrate it using your burette. When you've done that, you can use this thing called a volumetric analysis equation, which is this equation over here. It's V1 M1 over N1 is equal to V2 M2 over N2, where V stands for volume, M stands for the molarity, remembering that molarity means moles per litre, and N stands for the number of moles as indicated by the balance equation. What I mean by that is the number are in the equation which is before something. So if you remember back to your half equation of manganates and iron, you had 5 in front of the iron and 1 in front of the manganate. So those are the numbers you're talking about in this sense. I'd just like to also point out, I noticed I had a small typo in a couple of different places in the PowerPoint I uploaded. I will be uploading this PowerPoint back into the chat with the corrections on it, but if you are using the older version, please note that here I had written down 200 and it should have just been 100. It's just where I copied and pasted the centimetre cubed bit over and forgot to change the 2 to a 1. So in this question, which I'm just running through as an example, a student is trying to find the molarity of an unknown sample of KMnO4. To this, he completed the titration of acidified iron 2 sulfate with a known molarity of 1 molar and used the equation to find the molarity of the potassium permanganate. I've just plugged these things into the equation here. I find it helps to write out the equation or have the equation in front of you, then substitute in the figures that you have. And you can find out that when I sub in 200 for V1 for the volume of iron sulfate used, multiplied by the molarity of that, so that was 1 over N1, and I use 5 from that half equation, which you can see down here. 5 is equal to 100, which is the volume of KMnO4 used, multiplied by M2, which is what I'm looking for, and 1, which is that number in front of the permanganate ion in the half equation that we solved in the last lesson. You then find out that, M2 is equal to 0.4 moles per litre, or a molarity of 0.4. Hopefully you got to look through the quiz and hopefully you got along okay with that. I didn't hear back from anybody, so I'm assuming you all kind of did okay with that, or you haven't tried it yet. If you haven't tried it, I'd like for you to try it. And if you did try it, please let me know how you got along with it. In this second part of the lesson, which we were supposed to look at today, I started off by pointing out to you that sometimes the V1 M1 N1 is equal to V2 M2 N2. Could also be written as VO MO NO is equal to VR MR NR. This is just a kind of syntax thing. It just shows that sometimes things are being oxidized and reduced in your volumetric analysis equation. Right. So I'm going to let you read through how to do this method on your own, and then I'm going to run through this example question, which I was hoping to spend more time on in the lesson today. So a student crushed 5 iron tablets containing FeSO4 times XH2O and found they had a total mass of 9.769555 grams. The reason it's such an exact number is I made up these numbers. So they are a little bit exact to work with the rest of it so that you could still read through the samples given in the book and have them as slightly different examples. He then made this up to a 250 centimeter cube solution using dilute sulfuric acid and water. When this solution was titrated against a 0.2 molar solution of KMnO4, he found that it took an average of 3.5 centimeters cubed to fully react with 25 centimeters cubed of the iron sulfate solution. Find the value of X, the number of water molecules per iron in the iron tablet. Now this was my second typo in your version, if you're using the old one, this is find the mass of water. It should say the value of X, the number of water molecules per iron in the iron tablet. Now, I chose to write these out on paper. I find it much easier to write these out, and those are the photos on the next slides, which I hope you've already looked at. So in this side, I basically just plugged in the numbers I was given in the question into the equation. So this is all my oxidative stuff, and the thing which is being reduced the iron over on this side. It took 25 times y. I've used y as just a letter here to represent my MR, and I worked that out to be 0.14 moles per litre. Then in the next slide here you can see that we only had 250 centimetres cubed of our solution, so that was 0.14 moles per litre, or 0.035 moles per 250 centimetres cubed. The reason why we've done that is because the equation gives us the molarity. It doesn't give us the number of moles that we actually have. And the number of moles we actually had was 1/4 of a litre's worth of moles at the molarity. So 0.035 moles of FeSO4 times XH2O has a mass of 9.76955 grams. Therefore, if we divide that by the molarity, remembering how to get from mass to moles and back again, we can divide our mass here to find out our molar mass, or our molecular mass of this molecule. So we divide 9.76955 by 0.035 is equal to 279.13 grams per mole. 1 mole of iron sulfate with H2O is 279.13. We know that the molecular mass of iron sulfate is 152. We know that the molecular mass of water is 18. You can work that out from your periodic tables. Then you just add that into a kind of simple algebraic equation. The total thing should be 279.13. You've got so many numbers, so many molecules of the water. So you write 152 plus 18x, and you solve for x. X was 7. So for every iron molecule, there were 7 water molecules. I then asked you to read through the example on 15.3 on page 221. I think a couple of pages before that, there's another example of what I've just run through. And then I'd like for you to try questions 15.7 and 15.8 on page 235. I apologise, this is kind of a whistle-stop tour. I'm trying to keep it short to upload it and get it to you in time. I hope you're all well, and I hope to see you tomorrow. Thanks.